Let's start new topic, factor theorem. We learn about the remainder theorem. Now we are going to learn about the factor theorem. That is somewhat similar, but the viewpoint is different. Now, before we move on to the theorem, let's understand the meaning of the factors. Now, factors, we know very well. Let's say if we take factors of 12. So, what are the factors of 12? Let's say 1, then 2, 3, 4, 6 and 12 itself, right? Now, what we need to understand from this one, that if you divide 12 by any factor, right? Let's say 12 divided by 2, that is 6, 12 divided by 3, that's 4, 12 divided by 4, that's 3, and 12 divided by 6 is 2, and 12 divided by 12 will be 1. In all the cases, remainder will be 0, right? When we divide number by its factor, the remainder will be 0. So I can say that particular number like 2 is a factor of 12, 3 is the factor of 12, 4 is the factor of 12. But suppose if we divide 12 by 5. 5 2s are 10, we know very well, subtract 10 2 over here. We are getting the remainder over here. We are getting remainder. So, we conclude that 12 is not divisible by 5. This is what we know very well, right? 12 is not divisible by 5. Here we can say 12 is divisible by 2, 12 is divisible by 3, 12 is divisible by 4. Same we are going to do for the polynomials. Now we have two polynomials here. We have two numbers, like similarly two polynomials, and if you divide it and if you get the remainder 0, we can say it is the factor or it is divisible. We discussed one question like this as well, finding the value of k when the polynomials are divisible, right? Or it is factor, right? So this is the basic idea of this theorem, that if we are getting remainder 0 after substituting, like the case of remainder theorem, here we will always get the 0. Then we can say that it is factor, otherwise it is not a factor of this polynomial. This is what we are going to do that, right? So let's start with the question. Let's start with the first question. Using factor theorem, show that x plus 1 is a factor of x raised to 19 plus 1, right? I told you that if we get the answer 0 after substituting, the case of remainder theorem, right, will consider as the factor. Let's do the sum. So we have px is equal to x raised to 19 plus 1, and that need to be divided by x plus 1. Okay, so steps are going to remain same. First of all, we'll equate divisor equal to 0. X plus 1 is equal to 0. Let's shift toward that side. So x is equal to minus 1. This step is same. Let's move on to the next step. That is also quite same. So we are going to substitute x is equal to minus 1 into the polynomial. So p minus 1. Instead of x, there will be minus 1 raised to 19 plus 1. So I told you minus 1 raised to odd power will be what? Minus 1 only. So minus 1 plus 1 is equal to 0. So if remainder is 0, then x plus 1 is the factor of x raised to 19 plus 1. So we can write remainder is 0. So we can write it is a factor. Simple. If remainder is 0, then it is factor. Very simple to do. See, this is all about kind of calculations we have done that is related to remainder theorem only, right? But the main thing we want to get here is always only 0, nothing else. We only want to get 0 always, then it is factor. If we don't get, then it will not be the factor. Let's discuss next question. Let's discuss one more question. Same, with the same concept. Using factor theorem, show that x plus 2 is a factor of x cubed plus 3x squared plus 3x plus 1. So let's start. First of all, let's write about the px. Px will be x cubed plus 3x square plus finally 3x plus 1, and we are dividing with x plus 2. We are dividing with x plus 2. Simple. Again, we are going to follow the same step. First of all, we will take x plus 2 is equal to 0. Shift 2 over here. So we are going to get x is equal to minus 2. Now this value we are going to substitute into the polynomial and we'll check are we getting the remainder 0 or not. If we get remainder 0, then it is divisible, or we can say it is a factor, and if it is not, then we say that it is not a factor of this polynomial. So let's start. P here minus 2. So x cube. So minus 2 cube. Then plus 3x square. So minus 2 square plus 3 into minus 2 plus 1. So here we can write minus 8. Here minus 2 square, 4 3s are 12. It is minus 6 plus 1. So let's simplify. Here it is 4 minus 6, that's minus 2 plus 1 will give you minus 1. So final answer is minus 1. P minus 2 is minus 1. Now to be factor, we want what? 0 as the remainder, like we discussed. But we are getting minus 1 as the remainder. So is it the factor, right? It's not a factor. We want remainder 0, right? So we can write it is not factor. It is not a factor. So that's it, right? Very simple to do. You get the value of x from the divisor, that's x is equal to minus 2. Substitute into the polynomial, simplify and get the answer. If you get 0, it is factor, otherwise it is not. Let's discuss next question.